Hi, everyone. I think you can hear me. Quickly confirm. I guess you must have watched the previous lectures, previous videos where I had discussed about network analysis previous year questions, TSSPDCL, NPDCL. Now we're on to TS Genco. Okay. Don't think that this will be only for Telangana State Genco exam. Only if you're attempting for Telangana Genco, then only you should watch it. It's after all state electricity board. Okay, and we got some interesting questions in the previous videos, also previous classes. I discussed some very interesting questions, so that will help you to recall the concepts what you have learned. Okay, if you are starting afresh, then it will help you to gain some concepts. Okay, I hope we're good to go for TS Genco. Okay, TS Genco 2015 questions we'll see. Electrical circuits or maybe network analysis. I hope you're ready. Let others join quickly. Meanwhile, if you have any questions from the previous videos what I discussed, you can ask me. I'll try to clarify. Yeah. Do you have any questions? If you have some, feel free to ask me from the previous lecture, previous videos. Any queries if you have? Yeah. Good evening, Shubham. Good evening, Sampath. Shall we go to the first question then? Yeah. Good to go. What are we heading for? TS Genco network analysis, previous year questions, PYQs. Are you guys ready? Let's go for the first question. They're easy questions actually. Okay. I think you can answer it quickly, pretty quickly. Okay, let's see who is going to answer this question quickly. This is simple question, theoretical question. So 1 minute is good enough to answer this. Okay. Yeah, try. We got a question. Sampath, I'll come to your question. Wow. Ravi Teja. Lovely. This is for you. Lovely. Nice. Sampath, good. Good. Keep it up. Sampath, that's good. Ravi, fantastic. You answered quickly and correctly also. Others, what others got to do? Try something. Come on. It's easy. Theoretical question. If you're unable to solve these theoretical questions, means it's pretty clear you're not that confident with the subject. You have to watch the course. Okay, at least watch the free videos what are available in the app. Download the app, you'll get all those details. Okay, free videos are there, free test series are there. Keep attempting those. Okay, yeah. Okay, I think let me solve this. Time's up. Let me solve this. So it is said in a series RLC high Q circuit, we have RLC circuit whose Q factor is high. Okay, the current peaks at a frequency. At what frequency the current magnitude will be highest, its peak. Okay, people are saying C. Let's see how we got to C. Can somebody say the one who is saying C? Stunts dude is saying option C. Okay, so yeah, it's a series RLC circuit. Okay, normally current value will be maximum. Current value will be maximum when you have this is series RLC. In case of series RLC, we know Z is equal to impedance is Z is equal to R plus JXL minus XC. This is what impedance Z, right? Now, current value peak at resonance, what is going to happen? Tell me. At resonance, this will be 0. So Z is minimum. Z is minimum at resonance. Okay. If Z is minimum, we know from Ohm's law I is equal to V by Z. At resonance, impedance is minimum. Denominator is minimum. So current will be maximum. So at resonant frequency, you will have current, the corresponding current will be highest value. Okay. Frequency, this is frequency, this is a current. Now it's going to be something like this. Okay. At resonant frequency, you will have maximum current. So that's why series resonant circuits are called as acceptor circuits, because at resonant frequency it will accept all whatever its maximum capacity will draw the current. It will take the signal. Okay. Parallel RLC circuit is considered as rejector circuit, where current will be at its minimum at resonant frequency. Okay. I think we are good to go to the next question. Now, before I head to the next question, Sampath is asking a question. His question is, in delta connection, where is a return path? It's not necessarily in delta connection. Maybe in star connection without neutral, where is the return path? Okay. The other phases will be acting as a return path. For that to understand, I have already discussed that 3-phase. Why we are going for a 3-phase? Why not 4-phase? Why not 5-phase? Why not 6-phase? Why not any n number of phases, higher number of phases? Yes, they are existing. They can be used, but why we are sticking to this 3-phase? Why not even 2-phase? Those details I had discussed for free. You just go to the app. If you download the app, you will get all those free content accessible to you, or else you can YouTube it. Search in YouTube why 3-phase PiSquare Academy. You will get that why series question. It's not just why 3-phase, why 50 hertz, why sinusoid, why transformer in kVA, why AC in ton. Different questions are discussed in that. If you watch that why series, you'll get a lot of good insights. Okay. I hope you will go through that and you will get that. I'm moving to the next question. Okay. Bang. Timer is already running, right? Timer is running. You got a question there with you. This is again a theoretical question, simple question. Genco, you got simple questions. In SPDCL, we got really fantabulous questions. NPDCL also pretty good questions, but Genco, you have simple questions. Maybe within 30 seconds, you should be able to answer if you have the content, right content with you. Okay. Yeah. Wow. Anusha has answered it. She answered it as D. Fine. Right. Let's see what others got to say. Naveen, Raviteza. Yes, guys. You're right. You're right. Answer is D. Okay. This is simple question. Now, under what circumstances, you guys tell me, under what circumstances Z parameters will be added and Y parameters will be added and H parameters will be added and G parameters will be added. For Z parameters, tell me. Those who have answered the question already, for those I'm asking, can just quickly type. Sampath is saying C. Good. Very good. Anusha is saying for Z parameters to be added, series input port must be in series as well as output port also must be in series. Both input and output are in series. Then it is Z parameters will be added up. Okay. Anyways, so let's now see two-port multiplication. We'll be adding for Z parameters, H parameters and Y parameters, but multiplication is there only for T parameter, transmission parameter. That's why we use this. In case of cascade, if one after other, in cascade form, if you have something, this is a cascade connection means. In a transmission line or maybe in a communication line, if you're an electronic engineer, then usually you will have some sending end and maybe in between you have some amplifier or maybe some transformer, then again some transmission line, again some transformer, or again some communication block or some bridging circuit. Okay, so like this you usually have a structure something like this. Okay, so for those cases when you have these kind of thing, then it's giving a relation between input and output. Again this input and this output, again this input and this output. So this cascade connection, we have to go for transmission parameter. That's what that one is. Now, to get a complete block ABCD parameters or transmission parameters, you'll be multiplying each individual block's ABCD parameters. Okay, so ABCD matrix will be multiplied individually. Okay, again, this is not a discussion. This is just to recap whatever you have learned already. Okay, if you're not learned already, then Bhagwan can save you. You have to first go through the content first, concept first, then it comes to the practice, right? Without having a knowledge right now at the beginning, how can you practice? If you try to practice, you will lose your confidence. Okay, they are the basic questions, right? If you even take any course or you watch any free video, if you watch that if you complete that course properly, then you will be able to answer these petty questions. Okay, anyways, I'm moving to the next question. Okay, bang. If you're watching after the live, if you miss the live session, what you need to do, question number is already there. Of course, now it's not visible. Okay, question number and your answer, give it in the comment. You have to. Question number 3. This question number is 3. Wow. Stun duties answered it already. Sampath also answered it. Okay. Kranti Kumar is also answered it. Naveen. Wow, good. Keep it up. Keep it up. Keep it up. So I think 1 minute is pretty good enough for this, right? Yeah. Let me just stop the timer. So what it says, which of the following theorems enables? So what about the compensation theorem? What is the reciprocity theorem? Try to recap all those. What is the superposition theorem? When I told you in the previous video, superposition theorem, the beauty of superposition theorem when it comes to play, okay, we think that two sources are there and one is deactivated and another one is inactivated, blah 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 blah, all these bullshit we talk about, but why we miss the actual point. That actual point I discussed with the help of a question in the previous video. Okay, likewise Thevenins. Why Thevenins? I'm pretty sure most of the students doesn't know what is the beauty of the Thevenins. They know the Thevenins. Okay, Thevenins like this, step 1, step 2, step 3, step 4. These are the 4 steps you have to do it. Then you will get the answer. That's fine. But the real beauty of Thevenins, one has to know. Okay, there is a video again in YouTube itself, or you download the app, from the app, free video, free content. You watch that. Thevenins. Why Thevenins? What is the beauty of Thevenins? Why Thevenins is this rock star of all the theorems? Watch that, then you will get some good insights. Okay. So now Milliman's theorem. See all these Milliman's theorem, Norton's theorem, little tweaks of these Thevenins, you can say. Okay, so Milliman's theorem, don't think that it is only applicable to voltage sources. Directly, there was a question once in GATE exam, okay, I think 2019. Directly, Milliman's theorem question has come like this. There was a source like this, like this, like this, something like this. Okay. Now, if you have any sources like this, any number of sources with series resistances, then you can represent that with a single source and single resistance. It's true even for currents also. Okay, current source, and again a parallel resistance, again another current source, another parallel resistance. This is, they are in series now. Here they are in parallel, here they must be in series. If that is the case, then again you can represent this with a single current source and a single resistance. These were the concept of Milliman's theorem. Okay. Yeah. Now moving to the next question, if you're okay to go. Hi sir, there is a course on power systems in PiSquare other than MCQ. No dear, we have not right now. We don't have course for this power systems other than MCQs. CL what the MCQs are there, okay, and those MCQs we try to take that MCQs test series. Then solution, focus on the solution. In the solution, we have given complete detailed explanation of what is the answer and what could be the mistakes possibly students will be doing. Those things are well written there. Okay, so just take it, you'll get it. But yeah, for now we don't have anything other than MCQs for power systems, because we're doing with animations only all the courses like control systems and measurements, machines, anything. Okay, power systems, we're building the animation set. Okay, it's taking some time. Okay, let's move to the next question. Meanwhile, you try to solve this question. Timer is already running. Try to answer this. Okay. Wow, we already got the answer by Anusha. This is a simple question, by the way. Okay, basic fundamental question, which everybody should answer it. Okay, I think for this also 1 minute is pretty good enough. Okay, let's just stop this timer. Okay, and let's see. A network contains linear resistors and ideal voltage sources. Okay, when you get such kind of situations anywhere, if you get stuck somewhere, you quickly take some simple network. Okay, say simple network, you take it, then with some resistances, don't take too many resistances, take 2 to 3 resistances, or maybe 1 voltage source, you take it. Okay, then if values of all the resistors are doubled, I'm saying if you are clear with the concept, you should be able to answer it very quickly just by looking at the question. If by chance not clear, then quickly draw the circuit and do this, find out the current it is asked for, then voltage across each resistor will be how much. Okay, let's see. A network contains linear circuits. Okay, it's done. So let me take for you a circuit, simple circuit, if you want to have an idea on that. Okay, and yeah, I'm just taking this, or let's take another resistance here and short circuit like this, and I'm taking here, what's the voltage? Let's take this one as 10, this one as 10, this one as 5, and this one as 10 volts. Okay, Now, find voltage across each resistance. Let's talk about this voltage. Okay, what is the value of this voltage? Tell me. This voltage will be 5 volts right now. Right now, this voltage will be 5 volts, just 5 volts. Check it out. 10 10 in parallel, you'll get parallel combination is 5. And this 5 and this 5 in series, voltage will divide equally. So 5 volt will be the voltage across this 10 volt, similarly this 10 volts. Okay, I already told you some diamond rules for networks for you to solve the questions easily without any confusion. Okay, I know most of the students know the concept, but application is important. When there is a question, you have to apply properly the concept what you learned. For that, those diamond rules will help you. Anyways, so this is 5 volt. Now the moment everything has changed to its double, if values of all resistors are doubled, only resistors are got values got doubled, then what will happen to the total resistance which is acting upon this? The total resistance which is acting upon this will be doubled. Okay, so resistance R equivalent got 2 times of original R. Okay, so this got doubled. Now what is happening to the voltage across this? I is equal to we want to find voltage. V is equal to I into R. I into R is a voltage across each resistance. Now the resistance, each resistance value got doubled. Hence the equivalent resistance got doubled. Hence, according to Ohm's law, current has become half. Current has become half. So current has become half of its original current. So once you multiply these two, you will still get 2 to get cancelled. You will still get the same voltage. Are you clear or not? So answer is not change. There is no change in the resistance. Okay? In the voltage, in the voltage, there won't be any change in the voltage drop across any resistances. Okay? I hope we're good to go with this. Shall we move to the next question? We'll move to the next question quickly. Give it a thumbs up. Thumbs up. There's the thunder. Next. These are simple questions. I know they're pretty simple questions. Okay. And this is also theoretical, basic theoretical question at simple question. Graph theory from the graph theory, or maybe from mesh analysis also, you'll be able to answer this quickly. Okay, this question must be at your fingertips. Answer to this question, I mean. Yeah. Wow. Anusha is rocking. Good. Kranti Kumar is also saying. Correct. Very good. Keep it up. Ravit is also answered it. Only these 3 guys are repeatedly answering. Others, I think they're just watching like a movie, right? They have to answer it. Okay, again I'm stopping the timer here because it makes no sense of, for this question, if you're spending a lot of time, I think that's a real nonsense. Okay. Yeah. Let's see. Number of independent loops. If a network is having n number of nodes and b number of branches, then the network will have how many number of independent loops? Independent loops means we're talking about number of mesh equations, number of meshes. How many mesh are there in that particular circuit whose number of nodes are n and number of branches are b? Number of mesh or number of independent loops. That will be number of branches minus n minus 1 will be the number of mesh. That's what the number of equations. How many number of equations? Usually students do get confused here. Sir, I have a circuit But I always get confused for a given circuit. I should apply mesh analysis or I should apply node analysis. I always get confused with that. So how to get out of it? Okay, how to get out of it? That's what the real question. For that, these will help you. Number of mesh equations, how many you have, and number of node equations, how many you will get. How many number of node equations, tell me? In case of node analysis, if you want to go for a given network, how many node equations you will be writing? If number of nodes are n and number of branch equations are b, okay. For a general network, of course, there are some special cases. All those cases are discussed in the course. So with that, you will get, for a given circuit, whenever you look at the circuit, you should be having a clear idea of which analysis you should go, so that you will get the answer easily. Of course, both analysis will give the answer, but which will help you to give answer quickly? That's the real question, right? So those things, I think you should be aware. Now tell me, how many number of, for a given network, for the same network, how many number of node equations you will write for the same question? Yes, how many number of node equations you will write? Yep. Come on. What is the equation I mean? What is the equation for it? This is b minus n minus 1, which is b minus n plus 1, means C. Now if it is number of, this is number of loops or number of mesh equations. If it is number of node equations, then answer would be n minus 1. Yes, lovely. Naveen and Anusha, good, keep it up. Okay, moving to the next question. Muhammad is also saying answer as C, n minus 1, right? This is also pretty simple question. Okay, theoretical questions here, get it. Yeah. But previous videos, previous question session, we got really interesting questions, right? That will, you might think answer would be something, but answer is actually something else. Lack of mismatch of the knowledge what you might be having. If you are good with the knowledge what you have, then you won't do that mistake. Kranti Kumar has answered it. This simple question, Kranti Kumar has answered correctly first. That's what I think. No, that's not right. Kranti has answered it wrong. Raghu, everybody's saying A. Okay. For which question you're talking about? Are you guys talking about question number 6? I'm talking about question number 6. Is question number 6 is A? That's what you're saying, Kranti and everybody? Yes, Sampath has given it. Correct. Okay. So let's give it up for Sampath. Yes, very good. Very good, Sampath. Okay. So, a DC voltage source is connected across R, L, C. It's connected. Under steady state, we know for in this circuit, under steady state, resistance is not going to change its behavior, but the inductor at steady state will act as a short circuit and capacitor will act as an open circuit. As capacitor is open circuited, the entire voltage will appear across the capacitor only. So the applied voltage entirely will be appearing across capacitor only. Okay, capacitor only. Somebody's saying A, no, everybody's saying 6 is C. Yes, absolutely right. Kranti, Sandeep, and Candy. Okay. Let's move to the next question and the last question. Let's see how many of you are going to answer this question. Yes, let's see. This is something interesting. I think you need to take that 2 minutes time maybe. You have to know what is this ESR, equivalent series resistance means ESR. Okay, it's not something extra resistance. That's a equivalent resistance of the capacitor itself. ESR. Okay, this is basically something called ESR of a capacitor. That value will be usually very small. Okay, the value of ESR will be very small. I think that's a hint to answer even this question. Okay, value of ESR will be very small. That's why we don't normally talk about this ESR for capacitor. Okay, we neglect it. We take it as 0. Okay, this is a hint to even answer this question. Come on, this is the last question. I want you to answer it. Okay, give it a thumbs up and yes, bang it. No, this is not right. Anusha, you're saying D. Some people are saying A. Anusha, you're not right. Naveen saying A. Raviteza is saying A. Okay. Nice, nice. So, any more answers we got? Nothing? Okay. Let's go back. So, it is clearly ESR means equivalent series resistance. So, we have a capacitor. That capacitor is also having certain resistance. That's what series resistance. I'm representing it in series, definitely, and whose value is usually very small. So this is the resistance and this is the capacitance. Okay, now we know power factor is equal to cos phi is equal to r by z. Okay, I told you, compared to this xc value, this r value will be very small. So I can replace this z with simply xc. Okay, because magnitude of z is what? Square root of magnitude of z is square root of r square plus xc square. R value is very small compared to this xc. When I add something very small number, so it doesn't have a great impact. So that's why I'm saying simply xc. Don't neglect this numerator r. Okay, because it's in the numerator, it's not in the addition. If it is in the addition, you can neglect it. When you add a small number to, maybe you have 1000, you're adding 10 to 1000, it doesn't make a great difference. Okay, but once you divide that or multiply that, that makes a great difference, definitely. Okay, that's why when you're adding or subtracting, you will do these kind of approximations. Okay, so it is simply r by xc. So now it's asking about a power factor and frequency. Then what will do? R is equal to, equivalent resistance in terms of power factor and frequency. So from this, I can write R is equal to XC into power factor. Power factor is cos phi. XC is cos phi, or simply power factor, let me write. XC is 2 pi FC. So the only option which is matching is option A. So answer is also option A. Marked. Easy peasy. Right? That's it. That's all about today's session. Those are the number of questions given from network analysis. TSGENCO, there is something called network synthesis. Okay. So Foster form, core form, all these, that's a part of network synthesis. We discuss the questions from network analysis. I think you know the difference between analysis and synthesis. Okay. So if you have any questions on what I discussed so far, you can ask me. I'll take up those questions. Otherwise, we'll end the session. Yeah. If you have something, I would love to take those. I saw no questions are coming up. Okay then, that's it. Bye-bye. Have a good time. Catch you up in the tomorrow's session, where I'll try to take up other previous year questions after talk analysis. Then we'll move to some other subject. Okay. So what all you need to do? You download the app. There you'll get a free content where previous question discussion as well as some topics, confusing topics. Those topics also discussed for free. You can watch those for free. That's it. Yeah, take more examples. It's not I'm taking an example. It's a questions what is asked from the previous year. Okay. It's not my own creations. They are the previous year questions. So I'll come up with a few more questions in the next session. Bye-bye. Have a good time.